In this lecture, we'll look at how parameters are used in methods. Recall that there are two types of variables that we previously discussed. We have primitive type variables, so these are variables that store data of a particular type, and we have reference variables, and these are variables that store a memory address. So when we call a method, the value of the argument is copied into the corresponding formal parameter. So we're just doing a complete copy paste. So if the parameter is a primitive data type, then that means there is no connection between the parameter and the argument. And why is this important? Another way we can say this is any change we make to the parameter does not change the argument because there's no connection. So if I change anything in the parameter, the argument is completely unaffected. Let's try out an example of a method where we pass some parameters, and we can actually see this firsthand. That when we make a copy of the value to the parameter, it doesn't actually come back to our main. So we'll write a simple program. We'll call this params. And we'll start with our main. So public static void main string args. So in here, I'm going to create an integer variable called number, and let's initialize it to 6. And just to see what actually is going on, I'm just going to print the value of number in different parts of the code. So we'll do system.out print number plus. So that way we print a 6 there. And then let's do a method call. Let's say I create a method called formal param, and let's pass our number. We won't worry about what it does just yet. And let's do system.out.print number plus. Okay, there we go. So there's my main. So I'm just going to have this number 6. I'm going to print it out. I'm going to call my method, pass the 6. It's going to do something. And then I'm going to see what the value of my number is when I'm done with the method. So now let's define our method. Static void formal, if I can spell, param. And it's going to be int, and I'll call it num. So we'll print out what's going on here. So we'll say num plus. Okay, and then we'll say, let's set num to 15. And then we'll do system.out.print num. And then we'll save that. So save, call it params. All right, so what this is doing is in our main, we're going to have this number 6. We're going to print it out. We're going to call our method. We're going to pass 6 into num. So this num should be 6. And then we're going to change it to 15. So this num should be 15. And then we come back. We're going to see what happens in this line. What's the value of number when we're done calling it? So it's either going to be 6 or 15. So let's run. Well, we got to compile first. Okay, it compiles. Now let's run it. 6, 6, 15, and 6. So here's the point I'm getting at. So it was originally 6 when we initialize it. That makes sense. We call our method. So num is going to store the value of 6. So when we run this line, it's going to be 6. That makes sense. We change num to 15. So this line, which is our third value here, is going to be 15. But when we're done with the method, when we come back here, any change we made to num has no effect to anything that's done with number. These are two completely different places in our memory. So when I run this line, number is still 6. It's not 15. So that's what I'm getting at here. So if we just pass a value to a parameter, then any change we make to the parameter has no effect on the argument that we passed. Now, what if the parameter is a reference variable? We were still making a copy of the data from the argument to the parameter. But the difference, though, is the data that we're copying is the memory address of the object. It's not just some data, but it's a memory address. So this means that both the argument and the parameter are now referring to the exact same memory space. And the reason why this is important is if we make a change to the value of the object in our method, then that means the change is going to remain when the method is done, because I'm changing the same memory space that both the parameter and the argument are referring to. So if I change that memory space and then I go back to my original method, whenever I use the original argument, it's going to look at that same memory space that we modified. This means that reference variables are useful in 3 different situations. First is if we want to return more than one value from a method, because we can only use the return statement to pass one thing back. So if I want to modify several things, then I can pass a reference variable, make changes to the data associated with those reference variables, and then when I go back, then I have my updated values. So this is kind of a way of indirectly returning multiple values from a method. Another situation is if the value of the actual object needs to be changed. When we're passing stuff, sometimes we don't want to change the values in the arguments. But if we want to do that, then we need to pass the reference variable and change the data in the object. The third situation is if we want to pass the address to save memory space and time. Because we'll see some examples much later on where we can copy a ton of data to a method, but it's very inefficient. There's no need to duplicate all of that data and use up so much time to copy all that if we can just pass the memory address of the data instead. When we call a method, we're going to allocate extra memory to be able to compute all the operations that are done in this method. This extra memory also includes space for any any parameters that we pass and any additional variables that we want to declare, which we call local variables. Now, we've mentioned this before, but a local variable is just simply a variable that we declare in a method. And this variable lasts only until the method returns. Once the method returns, all that memory that we've allocated for the method is deallocated, and that includes all of the local variables that were declared in that memory space.